point. In this video we will prove virial theorem. First of all, we will define virial theorem. Statement: expectation value for kinetic energy is equal to 1 over 2 times expectation value of dot r and gradient of v, where v is the potential energy, which is equal to expectation value of kinetic energy is equal to 1 over 2 times expectation value of r dot gradient of v. To prove this theorem, we consider commutator of H and xpx, which is equal to H, commutator of H and x px plus x commutator of H and px. Here we consider one-dimensional case. We know when Hamiltonian act on psi, it gives us energy. So H of psi is equal to E of psi. Now we will take expectation value in any state psi. Expectation value of commutator H x px is equal to expectation value of H x px minus x px H, which is equal to psi H x px psi minus psi x px H psi. Now we will know when Hamiltonian act on any state function psi, it gives us energy. So it is equal to psi E x px psi minus psi x px E psi. E is the eigenvalue, we will take common. So it is equal to E expectation value of psi x px psi minus psi x px psi. This is equal to 0. So expectation value of H and x px is equal to 0. Now consider the Hamiltonian of any system. Which is given by Hamiltonian is equal to kinetic energy plus potential energy, and kinetic energy is equal to p square x over 2m plus v of x. Now we'll take commutator of H and x px, which is equal to t plus v, and commutator of t plus v and x px, which is again is equal to commutator of p x square over 2m plus v of x and x px. So commutator of t and x px is equal to commutator of p x square over 2m and x px. We will use this property. Commutator of A and B C is equal to commutator of A and B C plus commutator B commutator of A and C. So This become commutator of p x square over 2m and x px plus x commutator of px square over 2m px, and the commutator of this term is equal to 0, and commutator of this term is equal to minus 2 iota h cut px. So commutator of t and x px is equal to minus 2 iota h cut p of x square over 2m, which is equal to minus 2 iota h cut t. Now commutator of v of x and x px is equal to, again we will use this property. So commutator of v of x and x px plus x commutator of v of x p of x. Since v of x is the function of x, so commutator of this term is equal to 0, and commutator of v of x and p of x is, we will operate state function psi on this. So this become v of x p of x psi minus p of x v of x psi, and operator of momentum is equal to p of x is equal to minus iota h cut partial over partial x. So this become v of x minus iota h cut partial over partial x psi minus iota h cut partial over partial x v of x psi. So this become minus iota h cut v of x partial psi over partial x plus iota h cut v of x partial psi over partial x plus iota h cut partial over partial x v of x psi. So this become iota h cut partial over partial x v of x and psi. So commutator of v of x and p of x is equal to iota h cut partial over partial x v of x, and commutator of v of x and x px is equal to iota h cut x partial over partial x v of x. So commutator of h and x px, which is equal to commutator of t plus v and x px is equal to minus 2 iota h cut t plus iota h cut x partial over partial x v of x. Now we will take the expectation value of equation D. So this is equal to expectation value of commutator h and x px is equal to expectation value of minus 2 iota h cut t plus expectation value of iota h cut x partial over partial x v of x. In equation 2, we have proved that expectation value of this term is equal to 0. So this becomes 0 is equal to expectation value of minus 2 iota h cut t plus expectation value of iota h cut x partial over partial x v of x, which is equal to 2 iota h cut expectation value of t is equal to iota h cut expectation value of x partial over partial x v of x. This term and this term cancel out. So this become expectation value of kinetic energy is equal to 1 over 2 expectation value of x partial over partial x v of x. For 3 dimensional, this becomes expectation value of t is equal to 1 over 2 expectation value of r dot gradient of v, and gradient is equal to partial over partial x I hat plus partial over partial y j hat plus partial over partial z k hat, and this is virial theorem. Thanks for watching.